So welcome to this presentation for laptop to schools CTA scenario. Company information. Laptop to schools is a corporation which basically gets donation of laptops from corporations, and then they finally give those laptops either to school or to recycling firms. It's a manual process and they need a lot of automation. They are existing in US and also in Europe. They are divided into 12 regions. They are undergoing a rapid growth, and certain recommendations are needed from the architecture perspective to make their journey much more comfortable. Key assumptions and risks. So we are assuming that the school requests are less than 500 per month, so that web to lead would be sufficient. We are also assuming APIs exist or will be developed for the systems. One email will be sent for each PI laptop to the corporation detailing the files in which the PI exists. And one of the major risk factors is large data volume. So we plan to manage it by archiving of the solution as well as using external objects as and when needed. Org strategy. As far as this scenario is concerned, we don't see any need for multiple processes or some kind of adherence to some kind of a compliance like HIPAA or GDPR. There are no performance issues that we can see. There is LDB, but it seems like it can be mitigated by archiving and using external objects. So this is a straight scenario for a single org. We'll basically need multi-currency as well as multi-language. Also, territories are not used. It seems like the roles can do the job. Actors. So the first actor we have are the donation coordinators. We are giving them external apps license because they don't need sales and service. Next is the IT specialist for whom we are assigning sales because they need case and asset. The same thing is applicable to the SEC team. Then we have the allocation coordinators as well as their managers. Uh, as far as allocation coordinators are concerned, we're giving them service license because of the need of omni-channel. The security team manager is also given a service license because of the need to access the case as well as the asset. And the same is true for the L2S manager. Then we have certain external users. One of them is the volunteers. We're giving them Community Plus because of the need to access roles, because of the need for advanced sharing, primarily for that. Virtual experts are assigned Service Cloud license as they need omni-channel access, skill-based routing. Schools is another external license, and we are proposing community as well as TCRM because of complex reporting requirement. We don't see a need of giving a more advanced license than community at this moment. Corporations are also given external apps because of no sales service needs as well as for the recycle company. Students are just going to access the system for asking questions, and we are proposing that they will be using Chatter for that. So that's the license given to them. In this scenario, we are proposing just the rules and it's not used in conjunction with the territory hierarchy. We have the donation coordinators, school allocation coordinators, as well as the recycle allocation coordinators or ACs organized per region. So they will have per region specific roles. They will be reporting to the L2S manager, which is also organized per region. On the other side, in a different branch, we have the IT security specialists and they report to their manager, and they are not organized in regions, but they work at specific hubs. So they will be having like hub specific license. And the same thing is true for the security team and the security team manager. All of them report to the CEO. The external users that we have in the system, basically corporations and schools, those are owned by the DC. The volunteers are owned by the school AC, and the recycle AC basically owns the recycle companies who are accessing the system. What we haven't shown here are the virtual experts. They really don't need a role at this moment, so they are not depicted. System landscape. As we can see here, we are basing our solution on the sales and service fabric. We are planning to use omni-channel, multi-language, multi-currency, digital engagement for live chat, files for storing videos. We also proposing to use Conga Composer and Conga eSign for certain templating requirements as well as for e-signature that is needed when the schools receives those laptops. Because of complex reporting needs, we are also proposing to use Tableau CRM, and we'll go in detail for that. My domain will be enabled as that would be one of the prerequisites. As far as the external systems are concerned, we are proposing to use an ESP that will be used for communicating with the shipping system. The shipping system is assumed to have some kind of a REST and SOAP interface by which we can get the shipping information and transfer it back to Salesforce. The cloud storage, we are shown that they will basically having some REST and SOAP, but this system would be directly accessible through the mobile. And the line is not shown, but we are assuming like this system is directly accessible through the mobile. If additional support or additional security is needed, VPN will be enabled. The inventory is also assumed to have some kind of a REST SOAP interface, and it will be used by the ESB to communicate back and forth with it. We have two external systems. One is the asset management system from which the corporations send their laptops that is hosted outside of the firewall and assumed to communicate through the ESP with the inventory management system. Similarly, we have the government website which gives the pricing for the laptops, and that will be talked to by the ESP. We will not make a direct call from Salesforce. We are also having ETL in the mix for two purposes. One is to extract the information from inventory, like contacts, accounts, the laptops which are present, allocations historically which are present right now inside inventory, and basically put it inside Salesforce. So using the bulk API. The ETL is also used to archive the data off onto Heroku at predetermined intervals. We are also data virtualizing one of the objects we'll see in a moment from Heroku back into Salesforce. In order to satisfy SSO needs, we are assuming like they have an AD in place, and we'll be basically having ADFS that would do SAML SSO with Salesforce IDP initiated. As far as the communities or experiences are concerned, we are proposing to have a public website and a community for the school as well as the corporate. The public website is basically will be useful for signing up new schools or corporates into the system. We have a need for doing social sign-on for the school users, so they will be using OpenID Connect to log into Facebook or Twitter. Or providers will be set up in the system for that, and all necessary connections will be made. We are proposing to use SF Mobile standard application. It will be customized using LWC, and the same will be exposed to volunteers and schools based on the information they need. We're not going with the publisher because there are no specific requirements for branding at this moment. The mobile application will use the user agent flow to communicate with Salesforce as well as OpenID Connect for SSO. Integrations will come back in a moment. So coming to the ERD diagram, what we are proposing here is that we'll be using multiple record types to represent different entities within the system. So as you can see, we are using account to represent a corp or corporation. Recycle companies are represented by another record type as well as schools. The contact is represented by a person account with a record type of volunteer. As far as the nomenclature is concerned, I'm using a convention where on the left-hand side, I'm showing the organization-wide default, which is either private or CBP. On the right-hand side, the owner. At the bottom right, whether it's an LDV, the circle, and at the bottom left, it's the type of the object. C will be custom and E would be external object. And we're using like standard Grow Foods notation for showing master detail and lookup relationships. The critical object in this is definitely the asset. So asset is basically used to model the laptop. The asset is basically linked to multiple entities. First of all, the asset is linked to a product. So this basically represents a configuration. For example, a G2 laptop with higher RAM and memory. So that is a product and it will have multiple instances, which are the actual laptops. The asset is also linked to the external object called as software apps, which the volunteers are basically using to note what applications are installed onto that laptop. The asset is also linked to a donation batch because the corporations basically donate these laptops in batches and we want to maintain that relationship out here. The cases can be created against this asset because if there is a PI, personally identified information existing in that, so we are representing that relationship. It's a one-to-one relationship. And the case is also having a lookup to the user, the IT guy who actually made it. The asset is linked to an important object called as allocation. The allocation basically says that for this particular school, this is the laptop that is allocated. And the allocation object also is linked to the account. So we basically can build a relationship that this corporation donated this particular laptop. Then we have this account recycle that is also coming to the allocation, which also basically allows us to build analysis and provide data like this particular recycle company has been allocated this asset. So this object is kind of a critical object. The schools would be providing us allocation request. The allocation request basically contains what type of laptops they need and hence it is represented as a separate object. We are using work orders whenever the allocation coordinator for the school assigns a volunteer. So we will create a work order and the work line items would be the actual laptops that this specific volunteer needs to go and install within the school. So this is represented by the work order line item. And the work order is basically linked to a contact which represents the volunteer. The volunteer is having certain skills. The skills object basically represent the reference set of skills and the user skill object basically represents the specific skills this volunteer has. There are multiple LDVs in the system. Asset is around 1.5 million per month and the software app object is 7.5 million. We also expect allocation work order line item to be LDVs on their own. One important object that I missed is this bid object. The bid object is basically used to represent what is the price the recycle companies are willing to pay for a specific laptop configuration. That's what it is representing. And we have this notional owners like AC, DC mentioned out here. For LDV mitigation, we plan to archive off these objects into Heroku. At the same time, as long as there is huge data, we plan to use skinny tables, use optimized queries using query plan to see whether there are proper indices, custom as well as standard being used, and ensuring that the filters are properly present onto the reports as well as in the list views. Moving to the business scenario. So let's look into the first requirement. So the first one is laptop applications and donation intake. When the schools apply for a laptop, they currently download a PDF laptop application form and fill in the school name. They scan and submit it. So here we plan to use a community for the school, and they will create an allocation request containing the details. The request will be assigned to specific allocation coordinator queue, which is again region specific. The request is assumed to contain the region that allows us to do this routing. Corporates Corporations initiate a laptop donation process. In the first step of this, the CSV file is sent, which contains the laptops within the donation batch. Then the DC saves the file, runs a manual import process. So this is the current process they have defined. And at the end of this, they send an email to the corporation. So we want to automate all of these things, and we are proposing that there's a community being built for the corporations. They will access that community. There will be a tab present where they can upload a CSV file. The CSV file will have a very defined format. The amount of information is pretty less because we know like a donation batch may contain up to 300 laptops. The file will be passed in Apex, and we will basically have integration I001 executed. So the integration I001 is used to send the details of these laptops which are uploaded to the inventory, as well as update the shipping and send the email back to the corporate. So here we are using ESP to orchestrate this flow. We're planning to use fire and forget pattern coupled with platform events. And the whole process is in the following manner. The corporates would upload the file in the portal, the Apex code will parse it, and it will publish a platform event with a list of laptops. The ESP would be listening to this, and then it will take action and update the inventory with this information. It will also update the shipping system. It will get the shipping details and again publish a P with shipping details. There will be a SF process builder that would be listening to this P, which would get invoked, and it would then send an email to the corporate about successful publication of this donation batch into the inventory system. So here we're assuming like there will be uniform file format and a file size is capped to prevent heap size errors. Tomorrow, if there are like more size files, then we need to cap them. They can be broken into multiple pieces. Larger corporations have asset management systems, and L2S would like to give these corporations ability to send these details to the inventory system. So here we plan to expose a web service on the ESB, and asset management system will invoke it, and the ESB can then update the inventory. If we need some kind of tracking, then we'll basically have to like create another object in which each of these upload action as well as the invocation of the ESP by the asset management system would create a record. Next, we have L2S IT specialist checking the laptops for PII. Laptops contain PII, specialist should flag the record, and the L2S tech team should be notified. Email with a link. So here we are saying that the laptops will be modeled as assets, and we will basically have this integration tool flow, which is basically between the SF, Salesforce, ESP, and inventory. And it is for getting the laptops arriving at receiving hubs into Salesforce. So here we are assuming that the is the inventory is basically containing the laptops because they are getting loaded through asset management system. We need to make sure they are bought into the receiving hubs. And for that, we plan to use a batch integration. A cron job would be scheduled on the ESP. It will call the inventory system for new laptop records since the last watermark, which is the last pull, and it will pull the new ones and insert them into SF as assets. So this is a prerequisite that we need to have this new information or new laptops inside Salesforce. And once that information is there, the IT specialist will be checking those laptops manually one by one. And if they find any kind of discrepancy or PI record, they will check a PI field on the asset object. That will invoke a flow which will create a case and link it to this particular asset. Then there will be case assignment rules which will assign it to a security team queue in which we have this security guides. Criteria-based sharing on the asset will ensure that this particular laptop is shared with the security team public group. Next, we have the security team reviews the PI files, sends an email to the corp containing donation badge, laptop serial file name. The communication should notify the corporation with certain details. So here what we plan to do is we'll have a quick action on the case that will invoke a flow. Merge templates will pick up the fields from the case as well as from the asset which is linked to it. The file name and PI type will be actually typed in by the security team. So we don't want to use another object, but it could be like a long text area field in which we type all the file names of the case itself. And we are assuming here that one email will be sent for each PI laptop. Uh, so there are many laptops, but it's fair to assume that there will be like kind of like less scenarios as compared to more scenarios where the PI is found. Corporation does not respond within 5 days. The user who is assigned to the laptop should be notified that they have 24 hours to delete the file. So here what we plan to do is we plan to start a flow. So basically a flow will start and uh, it would kind of like trigger a time-based workflow rule. The workflow rule will monitor the email received from the corporate field for changes. So there will be a field which basically says email received from the corporate. It needs to be manually updated by somebody. So the time-based workflow rule is looking into that particular field. If this is not changed in 5 days, the status of that field does not change, which basically indicates no email is sent. The flow uh, will actually publish a custom notification, and that would change the case status as well. Okay. So because of the case status change, the security team can see all 24 hours deleted file laptops in a new list tree. So that's how we'll do it. When the L2S security team deletes the file, they remove the PI flag and the record should be reassigned back. So once the PI flag is removed, we will again invoke a flow. That flow will change the owner from the IT specialist uh, to the IT specialist based on the lookup on the case. So the owner is changed. That's how you will get the access back to the IT specialist. If the PI flag is not removed within 24 hours, record should be assigned to the sec team users manager. So in this case, we plan to use time-based workflow rule for 24 hours on PI flag. And that workflow rule will invoke a flow. The flow will change the owner of the case to the security team users manager by simply looking at the user.manager field, and it will provide access to the asset as well. The IT specialist completes the donation by adding details to the laptop and other fields. So here we'll just create additional fields on the asset of it. The IT specialist uses the details to register the laptop while the schools are recycling. Again, it's going to be a pitless field on the asset. Laptops designated for schools need to invoke a standard estimation, standard government website which provides an estimate for the price, and the designations and monetary values of laptops for schools should be updated in the inventory system in real time. So here we'll do this thing using the integration 3. The integration 3 is between SF, ESB. The ESB calls the government web service, uh, and then it basically updates the inventory. So the main purpose here is get the estimated price for the school laptop and then update the inventory as part of the second step with the laptop designation, which is for the school or the recycle or and the price. So we are planning to use request and reply. So when laptops save, it will invoke a flow and it calls the configured external service on the ESP. ESP will invoke the government website. It will get a price back from them and it will orchestrate the call so that it will directly update the inventory. So it doesn't need to go to Salesforce to do it. So this is a printing mistake. This is more like fire and forget and not request and reply. We don't need to do it immediately. Laptops should be assigned to school ACs or recycling ACs in the region based on the volume of records currently assigned to them. So here we plan to use omni-channel capacity-based routing, and the school ACs and recycle ACs would be assigned to those necessary queues, and the routing would ensure that the least available are not overwhelmed with more work. Second group of requirements around laptop allocation and shipping. So here we have the first requirement, which says L2S operating income is generated by selling laptops to third-party recycling companies, and recycling ACs would like to see the average dollar amount third-party recycling companies have historically paid. So for this, we plan to use a summary report, which is grouped by the laptop model, which is product, a recycling company, and averaged on the laptop price. And this information is present in our data model in the form of the product and the bid object. So if I go to my data model and try to show that, so basically using these objects, bid, product, the asset, and the recycle company, we can build a summary report and show this information. Next, third-party recycling companies need access to populated field or populated table, which can determine the rates that they will pay for recycled laptops. So here we plan to use a bid object. The bid object will be exposed to the recycle companies. The bid object has a link to a product. So recycling companies can mention the price they can pay for that specific bid. There could be multiple records indicating the dates on which the bid was made. So we can actually build a historical table or kind of a view that tells us what were the prices paid by the recycling company. The recycle ACs would like to see that list of top 3 recommended recycling companies. So here we plan to use an LWC component that takes the asset details and uses the bid table. So basically take the asset details and the bid table to find the highest 3 bidders. When selecting a recycle company for laptops, inventory system should be updated. So here we plan to use the LWC component to assign the recycling company and mask to the laptops, because we can't assign one company to each laptop. So we want to have a component that simply allows like something like drag and drop onto those laptops. And this information gets captured on the allocation object, which links the corporation, uh, not the corporation, the recycle company, which is this, to the asset. So that's how the allocation is made. And then we need to fire this integration 4, which is basically updating the recycle company information and assets allocated to them inside the inventory. So this is going to be fire and forget, and we plan to use Apex in the mix because of the involvement of the LWC component. So the LWC component, which has the Apex code, will publish a PE with assets and the recycle company detail, basically using the allocation table. The SP will listen to this platform event, and then it will invoke the inventory web service, which would eventually have this data. So going to the next one, the school ACs review the application for laptops in the region and run a search in the inventory system for those schools that have not received a laptop in 12 months. They would like to optimize the allocation of laptops by matching the requirements for a school app with the characteristics of laptop that are designated. So for this, we plan to use the LWC component to ease the search and basically do kind of like an en masse loop laptop assignment. So each laptop is an asset. There could be like hundreds of such laptops, and we want to create that relationship between that asset and the school. So instead of doing it one by one, we'll basically use LWC component, which matches the laptop with the product configuration. And once there are matches found, then the same component's Apex code will do a mass assignment. If the school has received more than 500 laptops in the current year, manager must approve the application. So here we again plan to use the allocation request. The allocation request will be compared against the allocation object. So going back to my data model, so here we have this allocation request. The allocation request is basically the request made by the school, while the allocation is the relationship between the asset and the school. So using this allocation object, we can actually find out the total number of laptops allocated for that school, and we could segregate that based on different time frames. And this number we can easily find out using the same logic. So number 4 requirement, LTOs would like to track the skills of each volunteer and their performance. So in this case, we have the work order created for the volunteer, and the skills object is basically containing reference skills. User skills basically map the skills this volunteer has. We propose to create performance field on the work order instead of creating a new object, and that's how we'll meet this requirement. Update the inventory system and automatically create a shipping record. So this is integration 5, which is very similar to integration 03, which we have already seen. So I will not go through that. The school and assigned volunteer should receive a school allocation letter, which contains a laptop delivery date, the list of corporations who donated the laptop, the total laptop value, and the contact information. So here we are saying that we'll use the Conga Composer template doc, which is created by linking the data model objects, allocation, assets, and the accounts that are involved, the corporation. We'll also have multi-currency and multi-language enabled using translation workbench. The laptop delivery date will be stored on the allocation request object because we'll get that through the shipping website. Next, when corporation should receive a tax donation letter, the total value of all laptops in both USD and the corporate's local currency, and they will receive this letter once the donation batch is fully allocated to the school or sent for recycling. So here what we plan to do is that on the donation batch, there will be a roll-up summary field that counts unallocated laptops, the count of unallocated laptops. If this falls to 0, it means that all the laptops are allocated either to school or recycling company. So if it falls to 0, we'll trigger a flow, and the allocation object, which is used to link corporation assets and the price, which is also stored on the laptop or asset, or basically the bid. So that will be used. So basically we use the price that is stored on the asset or the bid object, that is the price that the recycling company is willing to pay. So using this all, we'll basically build this Conga Composer template, and it will have multi-currency inside it, and we'll ship that particular letter or send that letter to the corporation. And next we have this laptop setup and support process requirement. So the need here is to electronically sign a receipt when the shipped laptops are received at the school. So here we're seeing there will be a tab which would basically allow them to do an e-signature using Conga e-sign within the community itself. Volunteers should be notified to schedule a visit to the school to set up the laptops. So here we are saying that once the receipt is electronically signed, it will basically have a flow triggered. It's kind of like the Conga has certain objects on which we can build a flow. and they capture the e-sign. So the flow will be triggered whenever this entry is made into this Conga e-sign object, and that would generate a custom notification for the volunteer, and that volunteer is obtained through the work order, which was already created. Volunteers visit the school and check in their mobile device. So for this, we are planning to use SF mobile app plus the LWC component for doing check-in. There could be a button called as check-in that will capture their geolocation. So essentially a custom uh, check-in page. And the geolocation coordinates would actually be stored on the work order itself, which is basically containing the lat long and as well as the time. So there could be fields created on the work order to be presented there. The volunteers begin to download the software. So this is assumed to be out of band, and we will basically have the connection between the mobile and the cloud storage directly. If extra security is needed, we will basically recommend using VPN. So there is a need to track the software name, and typically there are like 5 softwares. So tracking this requirement is kind of like LDV. There are 7.5 million potential laptops per month. Some of them will definitely go to recycling companies, but theoretically there could be 7.5 million entries per month inside a software application object if it were created on Salesforce. So hence we plan to use this as an external object, and also we have seen that there is no granular sharing requirement that is needed. So this makes sense here. Volunteers need to collaborate with other volunteers. So for this we plan to use Chatter. The schools who receive the laptops would like to record a thank you video note on their mobile device and share it with the corporations who donated a laptop. So in this case, uh, we plan to use the allocation object, which is basically containing all the information, the laptops that are allocated to the school and a list of all corporations. And it will be exposed as an LWC component within Salesforce itself. It will it will basically have a list of corporations. The Apex code can find out by going through these relationships between these 4 objects, and it will show a list of 4, uh, whatever the number of corporations are, which were responsible for the school's allocation. On the on that list, there could be a button which basically allows them to record a video, and once the video is recorded, whereas if it's less than 100 MB, we'll directly attach it to that chatter feed through a backend API. So the next requirement is that L2S has enlisted the help of 1,000 virtual experts to troubleshoot software issues. They also need a forum, and they can receive response from other students or virtual experts, chat in real time. So here what we are saying is that we'll have a public site for students, which will have chatter licenses. The Q&A or the forum is supported by chatter questions. We'll basically use digital engagement web chat for real-time chat, and omni-channel skills-based routing will be used for the virtual experts, and they are given an internal license because of this. So this brings us to the data model and migration requirements, which are not many. So go to the slide which basically shows that. So in our data migration uh, process, we'll basically use an ATL tool that will extract the data from inventory. And primarily the order of objects would be account, contact, which are containing the school and recycling companies, product, which needs to be created within Salesforce. And that will be part of the transformation and mapping logic. Assets would be representing the laptops, and finally the allocation. So all these objects will be loaded into Salesforce. The connectors will be present. We are assuming there will be an API for inventory. The connector can use that to pull the information. It will then clean dedupe. We have like a lot of duplicates, so we need some dedupe operation using SoundX or potentially using uh, some kind of another algorithm. And finally, these would be like uploaded to Salesforce's bulk API 2.0. We'll ensure that some kind of data is used, a subset of data in each stage of the development process, like 10% data migration testing is done in dev, 30% in QA, 50% in stage. Certain considerations to take is to turn off the automation, use deferred sharing, will ensure that group by parent ID is done to prevent locks, parallel mode used on a bulk API to make the whole process faster. Uh, at the end of it, we'll validate it and turn back the automation and finally run the sharing routes again. In this case, it's not mentioned what kind of migration is needed, whether it's Delta or Big Bang. But since there are like multiple regions involved, it makes sense to use a region-specific migration strategy. And that's what we'll do. And the subsequent will be the Delta migrations that will be coming into the picture, which are region-specific. Accessibility and visibility requirements. Corporations cannot see the other records. So this will do by private sharing. Only designated contacts or corps can see tax donation. So this is primarily a requirement using field-level security controlled by profiles of permission sets. Only users of L2S SecT and managers can see and update records. So here we are assuming that the sec team or managers become owners and they also have a relationship in the role hierarchy. The sharing is also auto-removed from whenever the owner changes. So the IT guy who actually reported the PI will not have the access, and that will ensure that this requirement is met. Only DCs can modify the laptop rates on behalf of the third party recyclers. So in our data model, the bit object is private and will have criteria-based sharing that shares the bit objects with the DCs based on region. The address donation corridor should only see laptop donations for the region. Again, this is a criteria-based sharing that will ensure is created on the assets based on region. And DCs are having a region-specific role, which helps us to do it. Corp tax ID and tax donation letter should be visible to DCs assigned to the corporation. So DCs would be assigned to the account team, and that's how they can get access to it. Only recycling AC should see the amount that third-party recycling companies pay for laptops. So for this, the bid object will have profile-based access off for others, and CBS sharing will be given on bids for the recycling company's ACs. Schools should be able to see all laptops allocated to them, but not see other schools' allocations. So for this, we'll have a sharing set defined on the location allocation object, and it will be using the rule allocation.account. So we have this relationship allocation.account is equal to user.account, and that's how the schools will get access to the allocation object. And we have master detailed relationship from allocation to the asset. But this is not correct actually. Volunteers should see details, laptop serial numbers, and shipping information only when they are assigned. So for this, we'll use Epic sharing. Internal users would like to access the system using corporate intranet, as well as its Active Directory, and they need automatic provision deprovisioning. So for this, we propose to use Identity Connect. Actually, we are proposing ADFS. This is wrong. This is not Identity Connect. Volunteers and schools need access to FB and Twitter. So for this, we will use social sign-in with all providers set up to use OpenID Connect with these providers. Next, reporting requirements. L2S would like to build a dashboard for corps that show 10 corporations related to the most. So this is a summary report which is based off the assessment and the corporate account. Schools should be able to see following history of all laptops that have been donated to the school, including allocations received, date the laptops were delivered, and other requirements. For this, we plan to use DCRM. The reason behind that is the data is archived because of LDB needs. So we might bring data from the archive as well as combine the data with whatever is existing in Salesforce, which is complex relationship of allocations, work orders, set, and the account. So we propose to use DCRM. List of software and license expiration dates for all laptops allocated to the school. Again, we need to use DCRM because we are using external object and also archive data. Finally, the requirement is around L2 is to see a trend report showing the number and monetary value of laptops donated by the costs by quarter over a period of 5 years. This is like huge amount of data, and most of the data will be residing outside of Salesforce. So okay, here the proposal is just to DCRM. Finally, coming to the environment section. So we plan to use multiple environments. Uh, the developers will be working in Scratch orgs or Dev orgs. They will do their commit of the code in Git. Once they commit into Git and create a pull request, the CI/CD pipeline will get triggered, and the code will be automatically be pushed into the CI branch. On the CI branch, which is basically using DevPro, we will be using or we will be doing certain system integration tests, and those will be done through Apex as well as Jest. The devs will also do their own integration test in the dev or Scratchbox instance, not integration tests, but unit tests, which are either Apex or Jest based. Once the pull request is approved and code reviews are done properly, the CI/CD pipeline will be used to push this information to the QA branch. The QA branch is using a partial sandbox, and it's basically focused on doing functional testing. There could be automated tests done to test certain critical scenarios. 10% data migration would be coming to the picture here, and then we'll do some kind of integrations with lower environments, which are there for the external systems. After this, the code will get pushed into UAT, which again uses a partial sandbox. And here the end-to-end testing is done. Data migration is done with higher volume. SIT is done, and then again more integration tests are run with the external systems. Important point here is to note that the amount of data migration percentage increases in each of these environments. Next, it goes to stage, which uses a full copies instance. And here we'll do load and performance test. A full integration test will be done with the external systems, and more data migration might be done. More than 50% of data might be involved there. Finally, the code is pushed into prod, which is a full copy sandbox, and there we do smoke tests. If there are issues found in prod which are super critical and need to be fixed, then they would be done by creating a hotfix environment, which is using a dev instance. The bug fixes will be done in the hotfix and then pushed to production. At the same time, these bug fixes will be propagated back to the lower environment so that they find their way back up. On the right hand side, we have this notional representation of the way the code moves from one environment to the other. We don't have any need of governance here, so I'll skip that. Thank you for giving me the opportunity to present laptop to schools. I appreciate it.